Hello, in this video we're going to look at finding the equation of secant and tangent lines. The function we're going to use is f of x equals 2x squared minus 5. We are going to do this using the limit definition of the derivative. And so the secant line is going to be the same thing as our average rate of change is going to give us our slope. And so remember, the average rate of change is f of b minus f of a over b minus a, where our a and our b are 1 and 3. It doesn't matter which one we call a and which one we call b, as long as we stay consistent. If we plug in the function value of 3 at the beginning, then in the bottom, then we're going to plug in that 3. Alright, so let's find f of b, in this case f of 3. Function notation, we're going to plug in 3 for x, so we'll get 2 times 3 squared minus 5, and that simplifies to 13. F of 1, we're going to do the same thing. Plugging in 1, we get negative 3. Excuse me. So what we're doing is just finding the equation of the line that goes through the point 3, 13 and 1, negative 3. This is just a different form for the equation of the slope of a line. And so now let's find our slope. That's going to be 13 minus a negative 3 over 3 minus 1. Again, it doesn't matter which one we plug in first as long as these come from the same point. So 13 minus a negative 3 is 16. 3 minus 1 is 2. And so we get a slope of 8. So we have our points, we have a slope. We can plug into our point slope form of a line. Y minus y1 equals m times x minus x1. Plugging those in, I'm just going to go ahead and use that 3, or the 1 and negative 3, just because it's smaller numbers. So y minus a negative 3 equals our slope that we found was 8 times x minus 1. Again, make sure that these are coming from the same point. Okay, if we go ahead and solve that for y, distribute 8. Y minus a negative 3 is going to be the same as y plus 3. Distributing that 8, we get 8x minus 8. And then to finish solving this for y, we get y equals 8x, and then when we subtract 3 from both sides, 8x minus 11. That is the same equation we would get if we had used the 3 and the 13 instead of the 1 and the negative 3. Alright, now let's find the equation of the tangent line at x equal 1 for this same function. So our point is going to be the same. X equal 1, we've already found that our point is going to be 1, negative 3. Now we just need to find the slope. So our slope is going to be the derivative evaluated at 1. If you're only doing this for one point, you can go ahead and plug in x equal 1. If you have to find the derivative and find a couple of different values of the derivative, then I would recommend doing it in terms of x, so you don't have to go through this whole process each time. But this one, we're only finding the line at x equal 1, so it's going to be the limit as h approaches 0 of our function f of x, in this case f of 1 plus h, minus f of 1 all over h. We are plugging into that same function that we had at the top. So that function was 2x squared minus 5. So we'll get 2 times, instead of x, we're going to plug in 1 plus h squared minus 5. All of that is our first term, f of x plus h, minus f of 1. Well, we've already found f of 1 is negative 3 all over h. We can square that binomial. Anytime we have a binomial squared, that's always going to multiply out to a squared plus 2ab plus b squared. So here our a is 1, so 1 squared plus 2 times 1 times h, that's going to be 2h plus h squared. We still have that minus 5, and then minus a negative 3 is going to give us a plus 3. We can combine like terms here on the end. I'm actually going to wait until my next step so that it completely goes away, because if we distribute this 2 here, we're going to get 2 plus 4h plus 2h squared. I'll go ahead and combine those. That's going to be a negative 2 all over h, and it should always happen that those constants completely add to 0 and everything that's left has an h. So we can factor out that h in the top. If we factor that out, we're going to be left with 4 plus 2h over h. We can divide out h on the top and bottom. So we've got the limit as h approaches 0 of 4 plus 2h, and when we actually take that limit and plug in h equals 0, we do get 4. So that is giving us our slope. We have our point. We can plug into our formula y minus y1. So y minus a negative 3 equals our slope of 4 times x minus 1. Y minus a negative 3 is y plus 3. Distributing that 4, we get 4x minus 4. And then when we subtract 3, we get 4x minus 7. And you can graph your original function, graph y equal to x squared minus 5, and our answer, 4x minus 7. And what you're going to see is we're going to have a parabola here that opens up. I'm not exactly sure where that 1 is going to be, but at x equal 1, our line is going to just intersect at that 1 point. So, all right, I'll see you guys next time.